Okay, today we're going to go over mixtures. I told you that I would go a little more in detail about mixtures, so that's what we're going to talk about today. Remember that a mixture is two or more compounds that are not chemically combined, so they're easily separated. And I say easily in terms of chemistry, like we could do it in a lab easily. It doesn't take a lot of work to get them separated out. So today's essential question, how do I know what kind of mixture it is? So we're going to look at the different types of mixtures so you can be able to identify what kind of mixture you're dealing with. The two main types of mixtures, you have a homogeneous mixture and a heterogeneous mixture. Okay, so the Latin root of homo means same. So basically what I tell everybody is it looks the same throughout. So you can't pick out the different particles that are in it. The best example of this is air. Air, if you look at the air, you can't see the oxygen, you can't see the nitrogen, you can't see the carbon dioxide in it. You just know the air is there, okay? You can't see the different particles of it. So air would be a homogeneous mixture. It looks the same throughout. Another example could be milk. So we've got air as an example. Another one would be milk. If you look at milk, you just see the white milk. You don't see the fats. You don't see the proteins. You don't see the water that's in it because it's all distributed equally throughout. So it looks the same. Air and milk are probably the two most common ones. So those are your main homogeneous mixtures, the ones that you'll see used the most for examples. Homogeneous mixtures do have something called a colloid or a Tyndall effect. So a colloid is just where you have really fine particles that are equally distributed throughout it. That doesn't mean that you're going to necessarily see them. It's just like there are dust particles in the air or pollen particles in the air, but you can't really see them. The only time you're really going to see that stuff, have you ever noticed if you're sitting by a window and the light is shining in and then you can kind of see little particles floating around in the air? That would be a colloid. And that what you're seeing, how you see the ray of sunshine coming in and it's highlighting the little particles that are coming in, that would be what's called the Tyndall effect. You can also see this with solutions when you combine some liquids together and it kind of looks clear, but if you shine a light through it, you can see little particles scattering the light throughout it. That's all going to be because of a colloid, the particles suspended in the mixture, and the Tyndall effect is just where you can see it with a beam of light. So that would be like the beam of light going through the glass of water that has stuff in it, or the beam of light coming through the window that's showing like the dust particles that are in your house. Okay, the next thing is a heterogeneous mixture. So hetero, the Latin root hetero means different. So this just means that you can see the different parts of it. So you can see the chocolate chips, you can see the flour, you can see the butter if you're starting to make cookies, okay? If you mix salt and pepper together, you can see the salt, you can see the pepper. You can clearly distinguish the different parts of it. So, let's see, I just said if we mix salt and pepper together. That would be a good example of a heterogeneous mixture. Another one, and I'm going to talk about it right here with this word suspension. If you mix mud and water together, okay, so we're going to put mud and water in a container. If you stir it up, if you keep stirring it up, it's going to just kind of look like muddy water, right? So you won't really be able to see all the different pieces of it. But if you let it sit, the mud particles are heavy enough to where they're going to fall to the bottom of the glass, and then the water is just still going to be in the glass. So it's eventually going to clear up. I mean, you see that at the lake, like when a boat drives by and it makes the water all muddy, and then if nothing disturbs it, then the particles settle back down and the water looks clear again. And that's called a suspension. A suspension just means that you have big particles, like the mud particles, that can be agitated, and it kind of makes it look like a mixture for a while, but then it settles back down. So then you can see the layer of mud, and then you can see the water on top of it. So that's what a suspension would be. Okay, if you mix two liquids together, or you have a solid that dissolves in a liquid, you're going to get a solution. So a solution is just where you have to have solute and solvent. Solute is what you're dissolving. And solvent is what you dissolve in. The universal solvent, the thing that most everything can dissolve into, is water. Okay, so water is the universal solvent. Okay, so if you pour alcohol and water in the same container, you have formed a solution of alcohol and water. There are ways to separate the two. It is not chemically combined. You can still get the alcohol out. You can get the water away from the alcohol. If you pour sugar into water, then you're still going to have a solution, and it's still going to look the same throughout. The solid sugar is going to dissolve. It's the solute. It's going to dissolve in the solvent. So it's going to dissolve in the water, and it just does something called ionizes, so it kind of breaks apart. You can still get the sugar out of the water. Okay, it's sugar water. It's all the way throughout, so it is going to look like a homogeneous mixture or homogeneous solution. But if you boil the water, the sugar is heavier than water. The water's going to evaporate, and it'll leave the sugar behind in the container. It would be the same if you do that for salt. So when you have a solution, you're going to dissolve a solute in a solvent, but it's still a type of mixture. You can still separate out the stuff. This is one reason why rising temperatures are a problem with the earth right now, because if you evaporate off too much water, then the salt is staying behind in the ocean, and that increases the salinity. It increases the amount of salt in the ocean water, because salt is heavier and it stays behind. So if you have it evaporating at a high rate, then you're becoming, you have an increased amount of salinity. It's becoming more and more salty. Okay, next thing I want to talk about is something called an alloy. You have probably heard this term, like when it comes to vehicles, like you'll hear aluminum alloy wheels. Alloy is just a mixture of metals. Okay, so to mix metals, you have to melt them. You have to get them in the liquid phase. So you have to heat them up, and then you mix them together. The reason that we have alloys is it makes the metals stronger. Alright, so it's going to make your metals stronger. So you'll have aluminum alloy wheels on a vehicle. The reason they're used in aluminum is because it's really shiny and it's really light, but it's also not really hard. So you mix it with another metal to give it more strength. Another example of alloys that you see all the time is going to be with jewelry. Rings are usually around 10 karat gold. And what that means is it's got another metal mixed in with it, so it's stronger. Rings, you're constantly grabbing stuff, picking stuff up. You don't want your ring to bend every time you pick something up or carry in the groceries. So you mix it in with a stronger metal, and it still has the gold look to it, but it gave it some strength instead of being flimsy like gold is. So alloys are just mixtures of metal. It makes the metals stronger. Okay, so if we go back to our essential question, how do I know what mixture it is? Okay, so the main two types of mixtures, homogeneous, heterogeneous. We break it down with the Latin root. Homo means same, so it looks the same throughout. Air, milk. Hetero means different, so you see the different parts. It'd be like salt and pepper, mud and water. If you mix mud and water, if you agitate it, then it will mix all up and kind of look the same, but then it'll settle out. That's called suspension. Colloid is like the rays of sun coming in through the window, and you see the little pieces of particles that are suspended just floating around. That beam of light that's shining through, it's a Tyndall effect. Solution is a mixture of liquids, or it's where you mix a solute and solvent together. They dissolve together and it looks the same throughout. Okay. Water, remember, is a universal solvent. And then we have alloys, which is a mixture of metals. You have to melt the metals, you have to get them in a liquid state, mix them, then they form a solid, but it's a stronger solid than it was before. Alright, so that's how you can tell the difference in mixtures.